I would like to talk about the important relationship between conceptual and procedural knowledge. What happens sometimes in our efforts to help shift away from this skill and rote practice is we say things like, we need to focus on understanding. And that is true. I'm an advocate for understanding. But sometimes when we say it, it sounds like we're pitting it against the development of skills, which is actually the opposite of what we're trying to do. We're working on conceptual understanding because it's critical to students really becoming flexible thinkers and good at solving problems, in other words, fluent in mathematics or proficient in mathematics. So as an example, I would like you to think of a story problem that you might tell for a subtraction problem like 58 minus 49. In general, the stories that we think of, and this is true whether it's a whole number like I just gave or whether it's a fraction problem, which I will share in a minute, but the stories that we come up with tend to almost always be takeaway stories. We forget about the importance of telling compare stories. Now think about how you might solve that problem, 58 minus 49. They're so close together that we might just count up 1 to 50 and then 8 more up to get our answer. A fraction example would be like 9 and 1/8 minus 8 and a half. Like, to think about the story that would go with that, if we do a takeaway story, we'd be at 9 and 1/8 and would have to take away 8. Whoops, I should go this way. And then take away 1/2. That is not the way we'd want to reason through it. We'd want to reason through it by picturing ourselves at 8 and 1/2, jumping up a half to 9, and 1 more eighth. So we'd have the 4/8 jump, 1/8 jump, 5/8. There's a difference between those two values of 5/8. Well, that means we have to help students understand subtraction as difference, not just subtraction as removing something. And that's a critical relationship. And that is true for all kinds of numbers, and we undertell stories that have to do with compare. And if that is the case, then we limit students' reasoning when it comes to finding the difference. And difference, as we know, all the way up through school becomes very important as we work on the difference of two squares and things like that. So it's very helpful. Then relatedly, to develop that conceptual understanding, the number line is a great tool. So we can reason on the number line, and that in turn helps students see ways they can solve a problem flexibly and not just use the standard algorithm when they don't need it. So there's a really strong relationship between students' performance when they understand, when they have the conceptual understanding with the procedural fluency. The two of them support each other. So a student who has a weak procedural background, their conceptual understanding can help them, but in the same way, a student with a strong with a strong procedural understanding, that can help them develop concepts. So we want to pair them up and always be toggling between the procedures and being flexible with the procedures and the related conceptual understanding. Why does this strategy work? So they're partners, they're not a choice, one or the other.